I would say that's worth it.
Well, if you're talking about 6, 7.
Time out.
You said I can.
Time out, guys.
You said I can roll back to the. When I didn't see anything, that's the rollback.
Go inside the 0, 0, 7.
But that one is talking about the work.
He's just got to try to start between the
Look for something that's not
Oh, I bet you.
So give us. Ready for a hive? The elephant-looking bee. Right.
Okay. I'll see the other.
Everybody.
What are you passing? Are you collecting?
How many are familiar with SQL? ANSI SQL. Wow. Would you interact with Hadoop if you don't have SQL? What do you do? Tomorrow I'll give you a Hadoop cluster. I need some data, guys. What you ask? Probably, hey, do you have SQL interface? I can query like SQL, right? So, as I said before, your data is great, your framework is great. If I can't access it the way I want it, I think there's a solution fails, right? So I think they understood that and they built this kind of interfaces, right? So, right, Hive, you have JDBC, ODBC drivers, right? What does it mean? Anybody can guess?
Well, JDBC is a standardized interface.
That is the database. But from when I have JDBC, ODBC, what you can do with it?
No, it's a database
Right?
connection.
Any standard tools can connect, most of standard. So that's the main thing here. So I can use Tableau, I can use any Microsoft ODBC controller, right? Probably MS Access can use ODBC to access your data on Hadoop.
You
So
have
that's
an
a big
ODBC
deal.
which is specific to whatever
Yeah.
you're connecting to.
Yeah. So that's a big deal because now I can interact like a typical database, like Oracle or MySQL database, and I can run some of the queries which look like MySQL. Not necessarily all the features of MySQL or Oracle, but look like MySQL, right? So it has a command line interface, it has a web interface. If it's possible, I'll show it to you. And it depends a lot on Metastore, basically. These all Hive will all connect to Metastore, then to the all this particular nitty-gritty of MapReduce behind the scene, right? So you can do some optimization just like in SQL explain plan. You can compile the code and you can execute it, right? So let's see.
So is it complete enough and similar enough that you could, if you're doing Hibernate development within Java, it's going to interface through that JDBC,
Yeah.
you can create DOAs and things like that?
Yeah, you're talking about ORM, right? Object Oriented Mapping, right?
Yeah.
See, ORM has a lot of foreign key relationship, all those things.
Right.
You don't get that here, right?
So since you provide the statement, even in Hibernate, you'll provide the SQL.
Yeah.
So you can provide simplified statements.
Yeah,
to the
yeah,
map. Okay.
yeah. I used Hibernate for hierarchical database. I had to modify my lot of code and do differently. You can do the same here, but I'm not really a solid web guy. I understand the ORM stuff.
But you'll be developing virtual objects
Yeah.
because they don't really exist that way.
Yeah, they don't really exist. And see, when you say ORM, you don't have rollback. You don't get rollback here.
Right.
Right. So, fair.
Well, it's read. You don't
Yeah,
use
read,
you don't
yeah.
use transactions on.
Yeah, no transactions. Yeah. So, and I also forgot to tell you, Hadoop is only upsert. You can append, you cannot update. Like select something from update to. That never happens. It's only upsert. The data is there, it updates it, or it inserts it. You mostly use for appending. You append the data, right? Because how do you update it? It's spread across the nodes. And how do you manage it? It's clustered, but it is not a distributed hash table. Distributed hash table work differently. That we talk about tomorrow when we talk about Cassandra. But here, we cannot do update because stored across. So that's not going to happen. So you can build some pretty interesting data warehousing on using Hive, right? It provides SQL-like interface, but not ANSI standard, not compliant, complete. Right? So you have high-level constructs like group by, count. You get all those, and you don't have to deal with this nitty-gritty of MapReduce taken care. And it's basically for batch process, like no real time at all. Pig is the same thing. Pig is abstract differently, like a interpreted language, the data flow. Hive is different. You can do some joins on different meta stores, but it doesn't provide a kind of real time. It's high latency. Right? You want to run the jobs overnight and build your data set so that you can query later. Right? So pretty much used for that.
So you'd use this for building subset data for data reporting, or to run reports themselves that are batch reports already?
If you go back to pig example, we had the map, we had the load functions, we did the processing. Once you store the data, now I can go back and use the Hive on top of it. Because I separate data, now I can put Hive and query like SQL. Right? That's what we're going to do. Right? So typical use cases, right? You can do business intelligence. I can use Tableau to connect to Hive. I can use Pentaho, if I have experience on that one, you can use it. And you can apply some data science stuff. And good for your application log processing as well. Right? So, it's for, not for these things.
Okay.
So, about the real-time query, so you cannot run a query and have it come back with data right away. Is that what it means?
Yeah, because it's going to take some time. Something MapReduce in the background. It has to spin up. You have to take startup time for the map jobs and Redis jobs, set up the job, check all the accessibilities, go across a node, get the data. 30 seconds. Even if you do I want limit 10, I want only 10 rows from this set, it takes 30 seconds. So that's not real time. That's too long for me. Right? So usually do it for batch oriented processing.
But there are other components that let you do real time against Hadoop.
Yeah. We want to come to that. Yeah. So it supports maps, arrays. The maps and arrays is a typical example. You can work on, you have a huge data set in a JSON format. I think everybody is familiar with JSON format. And JSON format can be complex sometimes. It has nested level, right? So you can still map. If you build your UDF to understand your JSON, I can use that to read the data through it, Hive, and explore arrays or maps. So it does support complex structures like that. So you have array in a JSON. I can export it in Hive and read each element. So it supports all those constructs. Right? You can partition it the way you want it. So you are reading a file which has a component, date component, right? And you want to partition the data in a metastore by year, by month, by day. So when you read it, I can define partition by this element of this value, partition by year. It creates a photo structure for you. So now, once you do that, I have another query coming on. You can work on a specific year because you're loading only that particular partition to do processing. So when you store the data, you can partition it. When you read the data, you can read on a partition. Remember, this schema on read. So you can apply the way you want, what you want to read, or what you want to do on particular set of data. So it supports that. So you can create partitions, buckets, you can define UDFs here, very similar to Pig. And if you structure your Java code such a way that the UDF is a set of libraries that I can use either in Java code, in Pig, or in Hive, or in application, web application. So you have one source of truth across the board, you can use it. So it's how you structure your application. So we go back to Hadoop example, Hive example. Everybody on this particular folder can see it? what you need to do here, just quickly switch gears quickly here. I need to do this meta store. I need to define how the file looks like, because if you look at when I say SQL, if you go forget this and go back to your Oracle database, we create a table, then I say select column 1, column 10, column 11, right? I need to define the structure, then do select. That's SQL style. The same thing, I need to define the schema of the file, how it looks like. We did the same way in Pig, we read it, applying the schema. Here, we create the schema before that. So, we switch the gears here. And if you open up,
Can you, what's the folder? Which folder you are in?
yeah,
O2 _
No, everyone knows?
yeah.
Okay.
the Hive.
I thought some people can see.
So I'm creating some tables here. I'm not associating anything, but I know how my line looks like, right? A row format, fields are deleted tab, end of the line, stored as a text file. Where is the location of the file? You remember we did this using Pig script. We created the wind records. Right? It creates a wind records table, which is going to sit here. And there is another one, a temperature, which is going to sit here. So you want to tell where this particular stuff is going to sit data. When I use this data to process, where it's going to sit. So we'll go out, and everybody follow my command here.
Can you read it out,
Okay.
Sanjay, so that we can
clear it
hear
out.
it also.
Yeah, I'll do that.
Go to the top.
Read it out loud.
Can you see it?
Hi.
Want to run that one?
Exception.
Ooh, I heard an exception.
Exception. Did the hive start?
Oh, well, that's great.
You may have to
Yeah, that's
clean,
good example here.
you may have to clean it up.
Don't worry. Right, started.
They have, what was that? Maybe the folder.
Please start.
Do you need to drop the tables first, Sanjay?
I'm the wrong one. Maybe it's not started.
Oh, okay. Yeah, you need that.
When you start the Hive, it's not started. Click on the Hive and you go to service actions and you click on the start. The one I was looking at, this is the Amazon setup. So don't be confused. It's starting, you see it's not starting here. Yeah. Clicking the icon, so it's starting.
What does that part mean, the Hive server to process connection requests?
Yeah, because like your Oracle server is not running. You're trying to connect from the client, JDBC, and it's not running. So I need to start the server component for your database so that I can talk to it, like listener. So I can start that.
Started. But it's still
Until I can't stop blinking, right? It has to validate environment and start. Started.
started, but still, what do you see the red one?
It'll go away. It's a UI has to refresh. Clean.
Is that the right time to do the analysis? Back to the top.
Start it on.
Input for oh, are you in the right field? Right folder? You're not. You got to go to high, 0 to high. Change the folder, change the directory. 0 to underscore high. CD to 0 to underscore. There you go. Yeah, you're there. You're good. You're good. No. You're there. Yeah.
How's a different photo? Able to see the output like that?
Oh, it says HQ. So just go
Everybody say Hive, just Hive.
Hive is a shell. It takes you to
Log into Hive shell. Everybody log into Hive
just
shell.
like Unix
Just type
shell.
Hive.
You're going into a shell.
At least now I have a little more confidence that I can scale it. Yeah, I think that's like 4 hours.
So we're able to get the shell. So now say show database.
Is this case sensitive?
No, it's not. See, there's something default all the time. So we have weather database. Weather database is like a schema in your RDBMS world. It's like a schema, right? So now we want to see the tables in the schema, then I have to go to the schema first. So use weather.
Standard database commands.
Yeah.
Follow the framework.
Yeah, MySQL is like you straight in. Now say show tables.
No, he said it was.
Then we have 3 tables: start, wind, temperature, and wind.
Okay.
Show databases. Then you say use database and show tables. Doesn't matter. Case doesn't matter.
How do you create the tables to begin?
How you minus F create tables?
Minus F is to say that particular
File name.
Into file, right?
Supplying that file name to
Yeah.
the shell.
Yeah.
Hive
It's
shell.
like running your
Type it in on
commands. Yeah.
Unix.
Yeah.
You won't understand it. You have to give it to Hive. Hive is a process, right? Not running in the background, but in this case, talking to the shell.
Now you say, let's say, let me do this, clear the screen. Select start from wind. Say limit 10. So it didn't give the headers here. I think there is a setting that I don't remember. But you want to see how the wind looks like, right? So typical describe wind. That's the table structure that we created. The string, the integer is a double, right? That's what they are.
So if you say instead of wind, it's select start from short wind, it gives you the maps and reviews.
Yeah, we're not there yet. Yeah.
Oh, we got
Right. So
Every command.
So we're converting every time you work.
yeah, it does. Okay. Yeah, that's your confirmation.
So we just ran a query and we looked at the data, right?
Yeah, exactly. So you see the response was very fast, and I said it's batch processing, right?
Right.
I wanted to come to that.
Okay.
Yeah.
All right. Yes, sir.
So I knew it was going to come.
We're getting
So
better.
everybody see here when I say everybody could able to do this select start from limit 10 or 100 records. Okay. So now you got the response really fast. Response was really fast. Why? Because when I say select start from, I'm not using map. It's like you're reading the file. Like you do that. What is the tail? You use command tail minus 10. That's what it's doing. I don't have to think. I just give the 10 rows. So why do I have to run map reduce for that? There is no map reduce concept needed at all. It's like doing a cat, right? So now, let us see here. This is the third one is wind speed.
short wind is
Well, let's wind speed is greater than 45. You're with me in this one? What should happen? What should happen when I say, give me a specific set of data from your file? What you will do? You don't close your eyes and give 10 rows. You have to go and pick and cut and paste into Excel sheet, right? Oh, this is the set. So that you are reducing your file to that set, right? So it does the same thing. It takes some time. It's launching the map reduce. Map of 1 of 3, 0 of 3. You start thinking because it sucks the data and it applies the map reduce. The picture I showed you in the beginning, the 4 strings. That's exactly what's happening right now. So now, Hortonworks guys mentioned about Tej. Tej is a speed in a small language, right? So basically, they took out the MR, map reduce, and installed Tej as the execution engine. What's the difference? It still took some time, but it's faster compared to map reduce. Why? When you do map reduce, traditional map reduce, every intermediate results are returned to a temporary file every time. So when you write to a file, read from a file, there's a huge amount of latency, right? So now here they're using memory. They are improving the performance using memory. Instead of writing to a file, they write to memory, depending on what the intermediate file size is, right? So it's a little faster compared to map reduce. So Tej sits behind all the time, so we don't have to worry about it. It's already assumed in Hadoop 2.0, it's always available for it. So now we saw.
Are you using Sanjay test for this?
Yeah, it's assumed by default. Yeah.
Did you disclose that?
Yeah.
Oh,
Yeah.
it's configurable.
So now I want
MapReduce
to
is like default. Default is MapReduce. Now they're using test. That's why it's fast. It's in your low ceiling.
if you look at select join,
So database.
I have a. We can do a join because it's like a table. It's like any database table. I have 2 tables. I want to join and see what's happening. Right? So we can do some join and we give a limit of 10.
One to finish this command, you'll have a carrot. Or you'll get
Say hive minus f input file, select join.
You seem to be still with the same.
You see there are three columns, math, 1, 3, and reducer. I have two tables joined. So what it does, it puts one table first in the memory, then takes the value, then compares the second table and gets the value. So that's why you see these three columns. Because it doesn't do like RDBMS. It sucks up to one set first, then does on like a cardinal operation, right? So
it puts to the memory.
one set puts in memory, right? Then compares other set and give the result here. That's your result. Yeah. So imagine you run on a huge set of data. You run it as a job, like every day, every week, or every month, depending on your needs. So it will, yeah.
So it would mean to say this, the elapsed time between running the same query in Hive versus MapReduce.
Yeah.
Its MapReduce will be faster.
MapReduce, no. MapReduce, it's always MapReduce in the background. MapReduce is happening, right? So now you're talking about a raw MapReduce, right?
Raw MapReduce.
Raw MapReduce. You need to be very good at Java. You understand how to use those partitioner combiners, how to use a mapper, how do I do the input split. So that abstraction is taken away from you, right?
Oh, okay.
That's high level. Now it just takes care of it. Now you can tune it to some extent, not to a greater extent. When you have raw code, you have more control, right? I can define a lot more parameters. I want to show it to you.
Oh,
Yeah.
okay.
You launch Hive, by default your MapReduce.
Depending on the statement. If it's just a select start from, no MapReduce, right? If you have join, filter, I need to think how to filter it. So you need a help of the resource, and you need to map it and reduce it. That's simple. Page is just improved upon MapReduce, and intermediate files are not created. And they use memory and file sorting, so they'll be a little faster. They need different engine.
Probably you can repeat the question and answer. Repeat the question. So
Yeah. He's asking why is different between MapReduce and Taste. Right? So Taste, it makes use of memory mapping. The raw MapReduce in Hadoop 1.0, whenever you run MapReduce jobs, every intermediate file is returned to a temporary file. There's a temporary folder in Hadoop file system that writes, then reads. It a lot more latency compared to using Taste. So what they did with Taste, they use the combination of memory and the file. Depending on if the intermediate data set is really large, then they use part of it to a file system, part of it in memory. So use that combination to make it faster. So using memory mapping makes it faster than writing to a file. So that was about Taste and MapReduce.
Now that you've created this weather, thinking of it like methods, the database, right? So then you have the table. Where are you creating it, or these are written into a particular file system somewhere, it creates it as a
Yeah,
terminal?
I'm going to talk about it next.
Okay.
So, as I said, if I go back to my this one, I talked about Hive Metastore. So whenever I created a table in Hive, it creates a metastore. There is a meta database, MySQL. By default, MySQL is used. MySQL is not used to store any data. You store data about data, metadata, right? It tells how the file is run. Why you need this? Why you need the metastore? Because if you want to use JDBC, ODBC to connect, they should understand how the table looks like first. Then they bring that information over here. So this serves the external interface at the same time command line. If you look at command line, they're no different. They actually sit on the same level. If you look at, right? It's only because I need to enable Java or ODBC based connectors coming from the third-party applications, right? So you need a metastore to understand how my schema is defined on this file. I can define multiple tables on the same file. One table holding 2 columns, one table holding 5 columns. It's very flexible, right? So you can choose what you want to, how you want to map your Hive table on top of your file system, right? So that's why you need a Hive metastore that nothing but stores the table information that you want to suck in and make it join or do some processing. So that's how, by default you use MySQL, you can use Oracle, you can use any other database, Postgres, we have multiple choice there. You can configure.
MySQL is delivered by default with Hive.
Yeah, it's in the ecosystem. Yeah, it is running actually. If you go back to Ambari, you must see.
That is what I did.
Basically, MySQL, they used to be open source. So then Sun bought it, then Oracle bought it. So then
So it came back.
Eventually, the source code was there with Apache.
There's still an open source version of it.
Version of it, the source code is still Apache owns the source code.